Ladies and gentlemen, good morning and welcome to MFTG. Today I would like to share with you some of the recent progress in meaningful type game theory. Our specific agenda now in the next couple of minutes is to describe you the class of games that we have already investigated, although there are a lot of open issues in this, so that you know what has been done and then what has to be done, or what we are going to do to get there, maybe to solve some open questions. So the first class of games is the class of games with selfish decision makers. A decision maker is said to be selfish if he looks at only and exclusively its own payoff. He doesn't look at the payoff of others. He focuses only on his own interest. And for this class of games, we have been looking at the outcomes, the equilibria, but also the equilibrium payoffs, and algorithms to find equilibrium and equilibrium outcomes, equilibrium payoffs, and learning algorithms to adjust and predict, correct, and so on until you reach something that is reasonably okay for everyone, and a lot of variations around Pareto frontiers and so on, although the game is non-cooperative. The second class of meaningful type games we have been investigating is the class of fully cooperative decision makers. So the player is said to be fully cooperative when is focusing on the only global objective of all the decision makers. So a game is in this category there is a common objective that could be, for example, the sum of the outcomes, but it doesn't need to be the sum in particular if it's not necessarily additive, and there is a common objective. It could be a vector payoff, for example, and everyone is concentrating on that objective. So in that case, the game is called fully cooperative, and we have been investigating this category of games, and the outcomes can be, for example, compare with Pareto frontiers and compare also with cases where some of them are not cooperative, and then see if there is any change, any difference, and explain the cooperative solution versus the fully cooperative solution versus the non-cooperative solution. And one of the paper in cooperative MFTG goes back to 2014, presented at the World Congress at IFAC in 2014, and coalitional MFTG and other extensions will be explained in the next class of games. Fourth class of games we have been investigating is the class of MFTG with spiteful decision makers, and a spiteful decision maker is a decision maker who is concentrated on the outcome of the others, but negatively. So he's trying to act against the outcome of the others. He doesn't focus, he does not necessarily focus on his own outcome. Is focusing on acting negatively on the outcome of the others. So it's a spite. And this class of games include, for example, adversarial behavior and many other classes. The fourth class of MFTG we have been investigating is the class of fully altruistic decision makers, and a decision maker is said to be fully altruistic if he is focusing only and exclusively to the outcome of the others. So he doesn't look at his own outcome, he looks at only the outcome of the others. So in this case, we have been investigating the different behaviors like mutual support, when they are fully altruistic. Is there any concept like that, and Burge solution concept, and the different type of, for two players, but for more than two players is more involved, although they are fully altruistic and so on. There need to be some designs and combinations. So several interesting results have been found in this category, and connections with other solution concept as well, which is very, very important. associated to the fourth class of games, we have extended it and we introduced the class of partially altruistic decision makers, because in practice, in terms of experiment, in terms of observations, so far we were not able to find decision makers who are completely altruistic, means fully altruistic. We have observed some kind of altruism there, but there is an explanation of why, and so on and so forth. So let's say partially altruistic, and that is observed in many examples, and you can find in our papers examples, for example, in communication networks, and example in economics, and so on. So partially altruistic decision makers, and a decision maker is said to be partially altruistic if for this time he's trying to look at not only the outcome of the others, but at least some portion of his own outcome. See? So that's very interesting. The sixth class of games we have been investigating is the class of games with empathetic payoff, and by empathetic payoff we mean the empathy profile of the decision maker is included. Fantasy scale, collaborative, and self-destroying, different type of behavior. So the empathy profile is measured, and then that will be included in the material payoff to construct an empathetic payoff. This is really very important, and I will connect it to other classes in the next couple of minutes. The seventh class of MFTG we have been investigating is the class of MFTG with other regarding payoff. So empathetic is one of the thing, partially altruistic is another thing, and so on. So by other regarding payoff, we mean the outcome of the others need to be included in your own behavior. So that's other regarding payoff, games with other regarding payoff. You look at not only your own payoff, but also other players' payoff. And this class of games is really very important, and it helps us to explain behaviors that are observed in practice. The eighth class of games we have been investigating is the class of games with cooperative player. So this time the players can be spied toward another one. It can be neutral toward another one in terms of outcome. It could be support toward another one, and so on. So a cooperative behavior, a game is said to be cooperative if you can have competition and cooperation together in the same outcome. So this is really very interesting itself to understand different behavior in the same game. You have competition and you have cooperation at the same time, and that's really widely observed, and we were missing the explanations in some cases. So these class of games help us to understand better this type of behavior. So this is really very interesting class of games to look at. This is a class of games with adversarial players, and by adversarial we mean somebody who is doing a minimax. I mean, he's acting in a robust way toward the other player. So if these two players is minimax, max min, and several solution concepts have been defined, and in terms of duality theory, and recently we have done a triality theory and more. The 10th class of games now we have been investigating is the class of games with risk-sensitive decision makers. So it could be risk averse, risk seeking, risk neutral, and so on. And this is really an interesting class because you might be have different attitude toward the risk. So some of them like the risk, some of them don't like the risk, some of them are neutral toward the risk, and so on. So it is a very interesting behavior. In particular, it's considered not just the mean, but also a higher moment of the payoffs and so on. The 11th class of games is a class of games with only and exclusively non-atomic decision makers, those who have a negligible impact on the main field, on the population main field, and that their decision, of course, is important in their own payoff, but it has no effect or small effect or negligible effect in the main field. So they are negligible decision makers, and that they are non-atomic decision makers. The next class of game associated to it is the class of atomic decision makers, and actually the atomic decision makers they have bigger impact and so on. So you have bigger games with players have two types of Minfield: the individual Minfield, which is the distribution of your arm state, and the population Minfield. Class of MFTG we have been investigating is the class of atomic and not decision makers together. So we integrate the last two classes together to have a more interesting profile. It means some players are atomic, some players are non-atomic, and of course we might have other structures like hierarchy that I will describe in the next classes. The 14th class of Minfield type games we have been investigating is the class of data-driven MFTG. So by data-driven MFTG we mean a class of games where the dynamics and parameters are learned from data. From the data we extract useful information, and those information will be incorporated in the game dynamics to build a game model. So that's the model is driven by data, and then we do measurement and we are back to the data. So it's done in a closed loop fashion. So game with data driven MFTG. The 15th class of games we have been investigating is the class of competitive games. So this is now more general, and the competition parameters are not static anymore, and you can be, for example, spied for a certain number of time, and then actually after that you become altruistic, and after that you become partially self-interested, and combination of those. So those evolve over time. So neutral, partially cooperative, and then partially spied, and so on. So these are evolving things, and in the competition we have a general cooperative Minfield type games. This is among the most interesting class we've been looking at so far. 17th class of games we have been investigating is now a class of games with variable leadership. So this is, people have been looking at the games with the leader, followers, and so on. Well, who decide who is leader, who decide who is follower? So the leadership is variable, and learning the different configurations among the hierarchies. So how many hierarchies and how many permutations there, how many leadership, and who is leader for what quantity of time, and so on. So games with variable leadership we've been investigating. 18th class of Minfield type games we have been investigating is the class of games with meta-learning in the leadership. So the meta-learning is on top of the hierarchy. You go and you look at how many hierarchies. If you have n players, you have n possible level of hierarchy, and at each of the level you can put a certain number of players and different combinations, and then you look at who will be at which level and who will be doing what, and like what we see in organizations. And then you find several possible configurations, exponential number of configurations, and this will be done in a meta-learning way because you have a learning of the learning process in this category. And this is a very important class of games as well. The 19th class of games is the class of games with psychological players, and in this case we consider not only material payoff but also the psychological state of the player, and that is variable again this time, and the psychological state is going to change. Somebody who is nice becomes somebody who is neutral, and becomes somebody who is less collaborative, and somebody who is acting against, somebody who is self-destroying behavior and self-abnegation behavior, and so on. So the psychological state of the player is measured, and this is changing over time. And the game should include it because the psychological state affects the behavior of the decision makers. Therefore, it affects his decision making, and it affects the outcome. So how to plug the psychology together with decision making to explain better some of the behavior that we observe in practice, and then go back and measure what is saying in practice and say, okay, now the theory is not just a theory, but it's something that is tested, observed, and we can correct it. We can come back and correct it, and then understand better what's going on. The 20th class of games we have been investigating is the class of meta learning on the competition now. So on top of the competition, we put a meta learning. So we want to learn the competitive parameters, and this is interesting because as the psychological state changes, the competitive things are going to change. And how do you see all the hierarchies and variable hierarchies, learning hierarchies, and so meta learning in this case is very interesting. So we put all these things together, and then we have 20 classes of midfield type games that have been already investigated, well, with open users. And of course there are many other classes of games that we will introduce in the next couple of months and years. Hopefully you are welcome to to contribute in this area. It's a really very exciting area, and thanks for watching, and see you soon on MFTG.